Hey everyone! Thank you for joining us for the next episode of our Spotlight on GitHub Advanced Security series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Thank you so much for joining.
All right, perfect. Thank you guys so much. Hey, everybody. My name is Elias Marquez. I am the CEO and founder of Canima. Today, we're going to be talking about shipping fast and staying secure. We're going to be going over how Canima integrates directly within GitHub workflows and how you can go through and have on-demand penetration testing as you are going through the development lifecycle process. So, getting stuff started, a little bit about who am I? I have roughly about 10 plus years in offensive security. I've done everything from networks to web applications, mobile, hardware, physical engagements, social engineering, a little bit of IoT, a little bit of car hacking here and there. If it's had a attack surface, I've at least had the chance, most likely, to mess around with it. I also founded a company called Achilles, which is a boutique penetration testing firm, and as already mentioned, founded Canima as well. How Canima essentially got started was roughly in about August of 2024. We had multiple clients at Achilles that were asking a pretty consistent question, which was, could they get automated pen testing? As of now, 2 years later, Canima officially made its debut, which is readily available for testing. So, kind of the whole reason as to why Canima was born, and particularly in how that integrates directly with and affects developers, which is, most of the time, developers lose a lot of context every time they have to go through the security process. Whether that is waiting on the security team to go through, reach out to a vendor, perform a penetration test, wait for those results, get those results back, perform the remediation, and then go through that whole process again to make sure that it's remediated before pushing to prod. The developers themselves have to leave the IDE, right? And in this case, maybe Visual Studio Code, GitHub, that sort of thing. They have to wait for scanning to complete and then having to decipher any kind of noisy report. And that's really the typical context in regards to the automated fashion side of things, right? So a lot of tools out there that are, SaaS related or DAST related, typically have quite a bit of false positives, which is about roughly 70%. When you transition to manual pen testing, that percentage significantly goes down, but the timing that affects the development life cycle was really the main problem here, right? When it comes down to staying ahead of your competitors, building out new features, or implementing, fixes, there is the understanding within the industry that if you push a change towards one area, sometimes it affects something that it should have been completely separate. So the main kind of point here being is that security shouldn't have to be a context switch. You shouldn't have to leave the IDE. You shouldn't have to wait to push to prod. You shouldn't have to, decipher a very noisy report to ever, um, you know, make progress in the app development lifecycle. So the first question I'm going to ask everybody here in the channel is, how are you guys currently solving this issue? What does your guys' normal process look like? Are you guys going through the automated life cycle, traditional SAST or DAST tooling, or are you guys already adopting AI powered tooling to reduce that issue? And then while we're waiting, if anybody has any comments on that, I'll just kind of quickly read through the chat here. All right. See, we have one question from Data Metal Machine talking about if we've ever or if I've ever hacked any kitchen appliances, fridge, toaster, and washing machine. The answer is yes. Not to toasters, but have done a little bit of fun here and there with fridges, particularly some Samsungs and whatnot. The washing machines, not technically per se. I just got really annoyed at the beeping that was going on at my house. So went through and found a way to be able to disable that. All right. So we have a few answers here talking about CVE scanners and CI/CD, Gripe and GitHub Actions, Wiz, etc. Yeah. Sounds good. Yeah, that's traditionally the current state of things to kind of help speed along security in most development life cycles. So okay, awesome. So what we'll be going over here within the rest of this webinar series is we'll be touching based on a few kind of key areas. One being, what is Canima? Two of talking about the technology, how it actually works, and how it's different from a lot of the things out today. We'll have a few Q&A pauses here and there throughout the presentation, and then we'll transition to a live demo of the a pull request going through on a sample repo and how that will actively natively integrate within GitHub for being able to deploy those issues, being able to see those, so the developers never have to leave the IDE or context that they're currently working on. Alrighty. So what is Canima, and why was it created? So Canima is a patent pending, autonomous, AI driven continuous pen testing platform, comprising of over hundreds of specialized AI agents covering web, API, internal networks, external networks, cloud environments, all being covered under the same environment. The product and AI infrastructure itself being built by hackers for security teams who need real-time context without the noise. We talked about the 70% average false positive rates on traditional tooling. So we're going to kind of cover a little bit of that as well, of how that actually gets lowered down to very negligible numbers. So where this kind of fits in, the Canima environment itself is not a scanner. It's not a consultant. It's not, something traditional that most people are familiar with. SAST and DAS scanners typically take, minutes to maybe an hour or so. Traditional pen testing can take a week or weeks, depending on the scope and sizing of the application. Meanwhile, Canima can take anywhere from minutes to, handful of hours to be able to bridge that gap between both of those. Traditional SAS and DAS scanners, as we already mentioned, false positive rate of roughly average of 70%. The dev workflow integration capabilities themselves, more or less partial, right? It is possible to go ahead and integrate those within, the CI/CD, which does, cover quite a bit. However, having to kind of jump back and forth, and myself having even previously experienced having to go through and mark different items as false positive, or clear text passwords being within the code base, even though it's just a variable name password which equals the supplied user input of password, it already flagging it as a higher critical, essentially drowning you in noise, right? The Canima system goes through, completely maps to what a real life adversary, real life hacker like myself would be going through and doing against the application, from more of either a black box to gray box to white box style assessment. The false positive rate is roughly about 0.1% on average, since every finding comes with a validated POC. The dev integration workflow as of right now, completely integratable via GitHub Actions. The cost difference between all these products, right, is that roughly Canima is 75 to 92% cheaper than that of manual pen testing. Typically, manual pen testing is performed maybe once a year, sometimes quarterly. It really depends on the scale of the application, how often you guys are pushing out new features, right? But the duration of the pen test and the cost associated with it really determines, in today's world, how often you can actually go through and get a real pen test, right? And how often you can actually get solid results that you guys can take action on. So for Canima, we already mentioned one platform, but covers 4 different domains. For the external network side of things, covering everything from DNS to exposed services, OSINT-based information, controlling different services that are going on in the external network, and then trying to exploit those. The internal network side, doing everything from AD enumeration to Kerberos-based attacks, lateral movement, and being able to comprise of full attack chains on the network side. Web and API, that's going to be our main focus for today. Covers everything from SPAs, REST APIs, GraphQL, WebSockets, matching those against vulnerabilities associated with, say, OWASP top 10, plus also identifies business logic flaws. The attack surface management component of Canima comprises of 24/7 monitoring, including anything related to new CVEs, certs that are published on online, dark web data, employee credentials, consumer credentials, found data leaks on dark web marketplaces, phishing domains actively trying to target your guys' infrastructure, or what we assume would be targeting your guys' infrastructure. And then we already talked a little bit about credentials and whatnot, but leak secrets as well. So this can include anything found online of API keys, secrets exposed in public GitHub repos, that sort of thing. But the overall understanding is that we are able to cover all of these environments under one platform, one domain. We'll talk a little bit about how the differences between how this can play amongst different types of teams, for instance, developers, security teams, and whatnot. But the overall idea is that Canima allows and gives you the ability to have everything under one roof. No more having to switch over to one company for web application testing, no more having to switch over to another for network-based testing, another for ASM, being able to have everything on a single pane of glass for you and your team, depending on your role. So we talked about what is Canima, but now how does it work? How is this different? How is this going to benefit my team? The overall idea of Canima was born, as I said, roughly about August of 2024. During that time until now, the environments, the code repos, everything associated with it, including the infrastructure, has been torn down, rebuilt, torn down again to get it completely right. The whole flow of everything comprises of multiple orchestrators, which then talk to multiple agents or workers, which have access to hundreds and hundreds and hundreds of different tooling, depending on their need and their speciality, which then translates everything into a project graph. We'll kind of go a little bit more into detail of exactly what these areas do, but the overall understanding is that the agents themselves are specialized in each area that they are testing. For instance, one agent's only focus is cross-site scripting. Another one is SQL injection, IDOR vulnerabilities, or if it's a network-based agent, Kerberos type of attacks, NTLM relays, that sort of thing. Another for JWTs, server-side request forgery, and the list goes on. We have hundreds and hundreds of specialized agents that their whole primary focus is just on those areas. The underlying premise as to why we did that, as opposed to going for one giant monolithic model, is mainly the same concept as you wouldn't be hiring a plumber to do an electrician's job, right? The same concept goes with a giant monolithic model. While great in a lot of circumstances, they lack key expertise in specific areas. When we are testing for cross-site scripting or SQL injection and so on and so forth, we don't need to be having to work with a model that was also trained on HR policies and data, right? Or SEO or anything like that. We want specialized agents that know exactly what they're doing, how to do it, and that's their whole job. That's everything that they know and are specialized in. The tools that then plug into those agents are all, defined by their speciality as well. But everything essentially translates to a project graph. So we kind of already really lightly touched base on the reason behind the monolithic model versus Canima's approach is that, we want specialized jobs or specialized agents for each and every single area of a web application, of a network pen test, and, so on and so forth. This way, one, we keep costs down, which then translates to costs keep being kept down for you guys, but also giving you guys higher ROI based off of the results that come back. So the how the agents work, right? We have a mixture of fine-tuned agents and trained agents that from the ground up. Everything that we do is completely proprietary and patent pending. So there is no third-party, AI provider that we are sending you guys this data to. There is no sensitive data or anything like that leaving our environments being translated to another third party. The main difference between Canima and say others who are say using a monolithic model is that if you wouldn't put a we'll say credit card into a LLM chat, why would we be wanting to send API keys or user credentials or PII, right? Or live client to consumer data. So that is kind of like the main reason there. But how that kind of plugs into those specialized and fine-tuned agents themselves is by essentially giving them two sources of knowledge. One on the left here is what we call our backend knowledge. So this comprises of everything that we've done at Achilles and available on the public internet. But every pen test write-up that we've done, redacted of customer information, of course, any CVE advisory that comes out, any exploit chain that we've given it, any payload variant, anything like that, that essentially kind of grounds that agent into what exactly comprises of a pen test and what it's actually supposed to be looking for, or how these things relate to each other. These agents are allowed to query that prior information before deciding their next move on an actual engagement. That knowledge itself is curated and tested and approved upon through our own R&D infrastructure. So that way our agents are kept up to date on the latest attack trends, on the latest vulnerabilities that come out. If there is a vulnerability that comes out from Cisco, the agent's already aware of it within a matter of an hour or so. The second half of it is that based off of the information that it already has on the actual understanding behind the vulnerability, the agents themselves kind of all correlate information together on a project database graph. And that has explicit relationships between assets to services running, to the users, vulnerabilities, the different techniques. It lets the agents traverse through those different attack paths and essentially ask themselves, okay, if XYZ works, what's next, right? What can I do with that? And those agents can communicate with each other. The orchestrators can set up different agents to have that communication as well. If one agent has a possible vulnerability that it thought was a server-side request forgery, but turned out to be a different vulnerability, it will then be able to transition that knowledge and that context over to the other agent specialized in that area based off of the information in the attack graph. So on the left, right, the kind of back-end knowledge kind of gives the agent information as to, how to find how to find XYZ. The database on the right gives the agent the information and back-end knowledge as to why and what's next. So whether it's the source code that was provided has XYZ vulnerability or XYZ vulnerability associated with it, can then take that to the live actual pen test, be able to do that information then and there, be able to chain it across different areas, be able to chain different low severity findings together to be able to transition it to something greater. So the agents themselves, we already talked about how that information is stored in those relationships that are correlated together, but the main real difference here is that the agents themselves don't have any direct access to any other client data, any other previous engagements that is currently going on, or anything like that. The way that we separate that out is by project, right? So when a project gets created or assessment gets created, there is a completely new database that the information is being stored to. So while the, say, application or platform of Canima itself is multi-tenant, the actual backend for how the data and how the agents handle the data is completely segregated based off of per organization, per project, per pen test. Alrighty. So, kind of before we move on, I think I see one question here asking if we leverage anonymized customer info to improve our models and products performance. The answer is yes. It's very dependent on specific use cases, but for the overall premise of things, we do have that ability to go ahead and kind of use that information to further improve our system, our models performance, and so on and so forth. And that's really the main goal of everything. No matter who we are. Interest in database backend Neo4j. No, we are not using Neo4j. Neo4j by default has everything in a single DB. It's very resource heavy. It's very limited in regards to being able to make it multi-tenant. You could technically make it multi-tenant based on the different relationships, but the main problem is that everything will sit on one graph. Your information with another customer, and so on and so forth. What we do is a little different, and that is using another one called Falcor DB, which is running cipher queries similar to Neo4j, but it gives us a lot more flexibility and actually faster than Neo4j. Alrighty. So we talked a little bit about the CVE advisories and how those are kind of integrated into the backend and how the agents operate. But the overall flow is when a CVE gets disclosed, whether it's through Hacker News or whether it's through the actual vendor, right, or whoever it might be, that information gets auto analyzed and parsed on our side, then gets validated in the R&D infrastructure, comes up with a signature, and being able to have that information readily available. That information then gets pushed out to the agents for them to be able to query and for them to be able to be knowledgeable about. The same underlying premise also affects the ASM portion of Canima. So when that new CVE comes out, it does all that stuff that we just talked about, but then will alert the actual customer if they have something in their environment that it's aware of and matches the CVE, right? So if they have Cisco equipment, that Cisco CVE comes out, they're going to get notified through the portal that, hey, this just got released. You might be affected based off of XYZ. Alrighty, so a few guardrails and safety requirements, just because that is the most important thing when dealing with AI, right? Since we are in a new day and age where, well, to be quite frank, you can social engineer a lot of AIs out there, right? A lot of different LLM products. You just have to ask the right question in the right way. Some LLMs will actually tell you how to be able to do it against themselves. But there's a lot of different guardrails that we have in place, not just based off of, say, prompt injection and LLM related vulnerabilities, but also guardrails in place of how the system actually interacts with your app, interacts with your network, and that is through hard-coded rules of engagements on every test. And these aren't just, I want to say, verbal rules, right? Or written down rules that you are passing over to an LLM. While we do have some of that in place, we don't rely on it. We have multiple systems in place, for instance, on the networking side of things. When it spins up a sandbox VM and is testing out the external network, it will explicitly put those URLs, those paths, those IPs into a kernel level blacklist, and will not, no matter what the AI tries, will not be able to communicate with those devices at all. Right. And then when it comes out to, say, testing web applications, sensitive areas, sensitive directories, anything like that, same concept still applies. They aren't just, we'll say, verbal rules, but mainly hard-coded things at the kernel level, at the tool level, that don't allow the agent to be able to do anything it wants or ignore ruling or anything like that. We already talked about the infra level project isolation, but the next part of that is also sandbox exploitation. So destructive based testing is disabled by default. So this includes buffer overflows. This includes DDoS related vulnerabilities, stuff like that. If a certain JavaScript library has a DOS vulnerability, it will make note of it. Try to get as close to a POC as it can to prove that the system is vulnerable to it or is utilizing that outdated library. But it will not go through and write a full working POC DOS vulnerability, take down production, or anything like that. The next portion of it as well is the audit trail plus the kill switch. So every agent action is logged and signed within the environment. We do have an emergency stop feature as well in the event that, hey, turns out we have a prod or a client demo that we're doing against the staging environment. We don't want to have the test being ran or something along those lines. Point is that it needs to stop. The emergency stop goes through and has multiple different phases, which is click it. You then get prompted for confirming it. And then within a matter of seconds, the entire backend infrastructure associated with the pentest immediately spins down. All right. So we'll take a quick break here and kind of open it up for questions and answer anything else that you guys might have. But some of you guys might be thinking to yourselves, how is this different from a SAST tool like CodeQL? What stops an agent from running something destructive in production, which we kind of more or less answered. The additional one could be, can it actually find business logic flaws or CVE patterns? That sort of thing. But we'll open it up for questions if you guys have anything that you guys wanted to talk about. But I'll give it just a quick few seconds. Alrighty. Okay. All right. So we'll go ahead and continue on, and we'll see if anybody else has any questions during that meantime. But we'll move on to the next phase of the talk here. So where does the pentest actually meet the pull request, right? How does this match the same speed of my development lifecycle or how fast I'm shipping to prod? So the entire loop that we'll kind of go over here in just a second is the developer opens a pull request, and then Canima will go through and do the rest. The PR gets open, the GitHub action triggers, the agents perform the test, and then the findings are associated with the PR, whether it's the specific files themselves for the PR, or in this case, since we didn't want to tempt the demo gods, um, um, findings inputted on the issues tab side of things. So for the developers, the findings get, as I said, findings in line with the PR. They never have to leave GitHub. Everything that the platform has to offer as far as the findings, reports, that sort of thing, all get transversed back to the developers within the area that they already live in. On the security team side of things, they're able to see everything that was pushed out to GitHub as well, plus also more, right? Not every developer needs to be able to see everything else associated with it, but in the security team's instance, they need to be able to see, everything that was done, the repo that was tested, the branch, every environment, stuff like that. Being able to do that on a continuous side of things, not just quarterly or annually. All right. See one question that came in. How do you handle false positives when multiple specialized agents are collaborating on a single attack chain? Good question. So we have quite a few ways to be able to minimize that, right? And that is through, as you already kind of mentioned, multiple specialized agents collaborating on a single attack chain. But within those agents themselves, having multiple, we'll say, managers, right? Which is essentially just the orchestrators. But those orchestrators are more fine tuned to audit and QA findings, attack chains, that sort of thing. They have a lot of the same information that the agents themselves have. However, based off of habits, patterns, that sort of thing, in regards to how we have gone through and QA'd our own reports at Achilles, that information and those flows and methods are then passed down to those types of orchestrators that are able to, catch those false positives and limit that to a really low level. Alrighty. So continuing on, what we'll kind of go through here is some actual live demo information. But in this case, we have a sample GitHub Actions workflow noted here. We can have this run, say, on a nightly build. We can have this go through and utilize our current targets associated with this repo. We can go ahead and have the secret key, aka the API key, for the Canima platform within this workflow as well. That then gets triggered and processes the pen test on our side. So what the developer will see when they go through and open that that PR is a vulnerability alert similar to like this, right? It's for instance a critical. There's a SQL injection at the API products search field, the exact payload response, or sorry, the description around it, the associated fix, and being able to view that information on the actual Canima dashboard. There's no portal, there's no login, no ticket. The developer has the same time frame as the same window that the PR wrote the bug in to be able to get notified that there's an issue, which is fairly similar and on par with SAST and DAST products out there, but incorporating this into a pen testing specific workflow, being able to have that depth that you would get with manual pen testing. So the live demo that we're going to do is show you guys OAS Shop, which a lot of folks are familiar with, but we have that in a private repo. We have a PR that we're going to do. I'm going to kind of show you guys more or less how that would work, showing you the exact approach from the platform to GitHub and kind of the differences in regards to what the developer sees, what the security teams will be able to see, that sort of thing. But alrighty, let me go ahead and pull this up. All right. And of course, the demo gods logged me out, so just logging that back in real quick. All righty, so let me go ahead and switch screens. All righty, so here we have the Canima dashboard that our current user role is manager level security team, that sort of thing. So we're able to see everything across the attack surface management, but also the web application results, network, internal, external network, that sort of thing. Here we have our GitHub repo, right? Fairly complex, very well known type and related test repo here. Here we have our IP address that we are currently running the OAS Shop repo live at, so we can actually go through, add this to basket, be able to see our product here, and essentially what will happen is if we wanted to go through and say do an assessment and trigger a web application test, we'll just say that this is test. We are wanting to do it against this IP noted here. Give the agent some context that this is a marketing site, has SaaS/B2B. It also has an LLM agent, right, or a chatbot type functionality. We also want to do authentication testing. We also have MFA currently in scope. We want to go ahead and do SMS, or we want to do mobile authenticator, or we want to go through that entire process. Or if authentication is being handled by a third-party provider, being able to note that down here put this in, whether it's Okta, auth ping, or so on and so forth, being able to have that information noted. If brute forcing is allowed, post exploitation, source code. Since we have our GitHub account integrated with our account on Canima, we can go through and automatically have the GitHub repository loaded here, or GitLab, or Bitbucket, being able to do source code review as well, and kind of go through there. And that's pretty much it. If we have any other secondary in-scope targets, such as like API, .xyz, or some other areas, then we have that ability to go ahead and input those here that, hey, the agent has permission to be able to, test that too, or being able to test information that's being sent to those providers. But in this case, instead of clicking next and kind of kickstarting that scan, we already technically ran one, but let me show you guys what the actual GitHub Actions looks like. So here we have the GitHub, or Canima web app pen test workflow. We have the function here to create an assessment. We want to be able to pass it our API key, API URL. Has the full curl request here of how that API actually interacts with the platform, triggers the scan, wait for completion, and then fetch the report and fail the PR if there's any critical severity issues that are identified. Now, the really cool thing between the integration that we have with the Canima portal is that on the integration side of things, we allowed the Canima bot to be able to comment on the GitHub repo based off of the either PR or through a manual engagement, anything like that. It will go through and essentially write those issues to the PR, or in this case that we went ahead and did, write those issues just to the repo based off of the pen test that was ran. So as you can see, when we go through and say, if we were to do a PR, this would immediately fail because we do have one critical. We do have another one and another one here as well. If we go through and take a look at this, we can see that the remote code execution affected this B2B V2 orders directory. We can see the associated proof of concept. We can see the remediation information. And then we can actually see the exact finding if we were to go ahead and navigate over to the Canima portal. The really cool thing between the integration of the Canima system with GitHub is that we have a one-to-one ability to be able to pull issues for, say, CodeQL, Dependabot, and so on and so forth. So you can see here that we have some issues that come through with Dependabot. All this just provides the agents extra context as to being able to confirm that these issues actually exist or not. The differences between this is we have about roughly 23 issues coming from Dependabot. We have roughly 25 issues coming from Canima that are confirmed. So we can see, let's see what another one looks like. We can see a SQL injection vulnerability that comes through. We have a description remediation. This one looks like it trimmed the proof of concept. I wonder if it maybe got flagged by a regex or something there. But let's go through and take another look at, say, this one right here. It looks like that one did too. But either way, the whole premise, right, is that the Canima system has that ability to be able to integrate directly with the GitHub system. So when those developers are able to go through and push, changes out, they're able to always see, what comes back from Canima. So within, say, the platform side of things, and we go through and start looking at, say, some of those issues as well, we can see quite a few highs. We can see some more lows, or some criticals and then some lows. We can see some bypasses that happened here. And then we can also see the GitHub advisory references. Looks like quite a bit of these findings as well directly link and correlate with Dependabot, and being able to actually pass that information over to the security team or the developers themselves, and having that one-to-one comparison between them. The whole premise as to why you get a penetration test is to be able to see the actual report, right? To be able to see the findings that are produced for a engagement, and being able to actually correlate that to activity. When it comes down to manual pen testing, one thing that I've always told clients over my years of pen testing is that it's one thing for somebody like myself to say you're secure. It's another thing for me to prove it, right? So it's one thing for me to hand you a blank report that said with a green checkbox that says you guys are good, no findings or no issues, weren't able to do anything. It's another thing for me to provide you a report that says, hey, we weren't able to find anything, but this is what we tried. This is what we did, why it failed or why we think it failed. These are the different techniques that we tried, and this is what was applicable to this, and this failed too. Or if there wasn't misconfigurations, being able to show that a full attack chain and that full context as to why, right? Being able to prove that you guys are secure. Same concept goes with say something like Canima. It's not just producing findings. We're going to go through and look, say, at the executive summary, being able to see everything that it provided here, being able to see the technical overview of the different things that it tested against, the risk profile by category, why that is in this case, or the attack narrative itself. Trying to go through, do some passive fingerprinting at first to try to identify the use case of the application, all the way to doing authentication and authorization type testing, seeing if it can work as different users, horizontal, lateral privilege escalation, that sort of thing. Input validation and injection testing, the different things that's trying here, what succeeded, what failed, data exposure testing, and so on and so forth. And then starts listing some possible attack scenarios as well, right? So that's really the main difference. And this is what kind of bridges that gap between, say, a traditional SAST or DAST tooling and full-on manual pen testing. The goal behind creating Canima was to essentially kind of create a digital version of myself, or at least, what I would do myself during a pen test. Being able to translate that into data for the AIs to understand, for how to write the reports, for how to organize their thoughts of what relates to what. This vulnerability relates to this service, which then can be relayed or used for this one, and so on and so forth. But being able to have all that information out within a report is what is going to prove to your security team that hey, this is an AI pen test, but we have the proof as to what it actually did, and has that audit and that accountability to the different things that it tried during that engagement. Same thing as what a real penetration test would provide, and not just that blank, green checkbox of you guys are good. All right. So with that being said, we can go ahead and transition back to the slide. All righty. Okay. So the four things that were promised to you guys, right, was running pen tests from GitHub Actions, which we were able to show how that integrates, which we can have run on PRs, we can have run on merges, or on a nightly schedule. It really just depends on your guys' preference. If you guys are shipping to prod every day, every hour, then maybe do it on a nightly or weekly basis. Or if you just want to test on the once a month PRs or the once a quarter, is really flexible in regards to how that actually matches your guys' environment, matches that scale, whether you guys are, pushing at the speed of go-kart racing, or if you guys are pushing to prod at the speed of F1, right? The exploitable findings with PoCs in those workflows, within each finding, each issue, each exploitable finding is matched with the POC to actually show the developer what the problem is, how to be able to reproduce it themselves, and then being able to query that for retesting and good to go. There is no having to hop in between portals or anything like that. Simply set up the GitHub Actions as to how often you want it to run, and you get back the immediate results as when you would like them. The unified visibility for the different security teams on one dashboard, single pane of glass, covering web, API, internal, and cloud, and being able to have that continuous and context-aware adversarial type testing from AI, matching what you would normally get during an actual manual pen test engagement, but much more in depth than traditional SAST and DAST based tooling. So, know we're kind of coming up on time here today. The other 75% of the platform that we didn't get to go over would be, going through, say, internal network pen testing, which we already briefly mentioned has full capabilities the same way as network pen testing goes, with AD enumeration, AD attack paths, Kerberos testing, NTLM relays, lateral movement, the whole shebang. External, being able to monitor AWS, Azure, GCP, your company's OSINT footprint, exposed services, leaked secrets, credentials, full attack surface enumeration at scale. The ASM portion as well plugs into the external side of things, but being able to have that ongoing visibility into your guys' external footprint is really important, almost as important as the products that you guys are shipping out to your customers, B2B or B2C. Alrighty. So we'll go ahead and kind of open it up for a little bit more questions as well on the demo and what was shown. We'll give it just a quick little few seconds here if anybody else has anything as well. And I'll kind of quickly go through the chat that was before. Let's see here. How are you sandboxing simple container workflow? Micro VM, GS. Gotcha. So sandboxing itself is done through containers, Docker containers that we have stood up, and it really depends on the test that's being done or the type of test that's being done. But yeah, everything from the tooling to the agents that they run on, that sort of thing, is all done via Docker containers. If you are talking about the sandboxing of projects themselves, we already kind of touched base on that, which is separate databases per each project. Alrighty, so we'll kind of go ahead and get started on wrapping up here in just a second. But kind of some closing arguments here, right, is that with Canima, pen testing becomes more of a line item and not a annual or quarterly project. Being able to have that on an ongoing premise, whether for web applications, whether for network, and so on and so forth, really allows the team to be able to scale as need be. The simplest cost comparison that I can give as well is for the same price as, say, a traditional one-time manual pen test, you could get 75 to 92% cheaper engagements run through Canima at a much higher of a scale. A quick number could be, say, for the price of a one-time pen test, could equate to roughly 6 times per year or so, right? That kind of ROI is not to be ignored. It's very easy to be able to correlate that and map that as to the value that you guys would be getting back based off of how often you guys can run these types of pen tests. See here, can we access this GitHub repo, and is there labs available? Yes, so the GitHub repo that we utilized here, we just did a simple fork over, but I can go ahead and provide that repo in the chat as well if you guys wanted to go ahead and take a look. Let me just go ahead and paste that here. Oh, actually, there we go. All right. Okay, so kind of jumping back to how this kind of shifts, right? we already talked about how often you guys can run it, whether it's every PR, every night, once a month, once a quarter. It's really up to you and really up to what you and your security teams agree to or what the security teams dictate. Um, really just depends. The coverage difference, right, is that for manual pen testing, it's still point in time. The Canima side of things is continuous or, full surface type of approach. Um, at all time. The kind of main takeaway from this specifically is, what would you and your team be able to do with, say, 50 times more pen testing coverage than that of just the one time a year or the once a quarter, whatever you guys are currently doing. Um, See another question here for how do developers typically validate reproduce findings directly from the generated attack narratives? Yes. So the PoCs that are provided within the GitHub issues themselves or on the findings tab of the Canima portal give the developers the exact string to be able to simply copy and paste to verify the information on their own, whether it is a curl query, whether it's a specific tool and the specific commands and the expected output. But it will give them the exact information that they need to be able to reproduce those findings on their own, along with any additional information that the agents have available. If, say, source code testing was provided as well, or sorry, was performed as well, being able to show the exact backend code affected, the associated remediation is for that as well. Alrighty. Just a quick kind of recap here. 3 audiences for one platform, being able to cover the internal security teams or internal teams in general, right? From the security analyst, security engineers, the developers, compliance team, whoever it might be, being able to accommodate them within the platform, being able to also accommodate both MSSPs, VCSOs, that sort of thing, within the platform, being able to offer these types of services to their customers, and then also the ability for boutique pen testers to be able to use this to offload, a lot of manual services, or being able to use it as a good additional starting point for them, right? If we have Canima go through and perform all the hard work, the consultants get to go ahead and have that information and being able to try to see if they can find anything else or anything different, not having to kind of essentially re-find issues that Canima went ahead and did, but rather already have a ton of stuff in their backpack for the engagement and being able to go off of. But, alrighty. With that being said, I believe that is it. The GitHub action side of things is already readily available. We have a few plans for some direct integrations within some IDEs. And then within Q4, we have some plans for AI-driven auto-remediation as well. But yeah, with that being said, I can open it up for questions here. I'll still be around for a little bit, but thank you guys so much for having me. Thank you to the Reactor team as well. I look forward to chatting with you guys again sometime, and look forward to diving into detail some more.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.